Another important idea related to rates is what happens if we calculate an average rate over shorter time intervals. If the blue curve represents a function, then the slope of the red line represents the average rate of change between this point on the curve and this point. For example, the average rate of change of depth between the clock time corresponding to this point and the clock time corresponding to this point. If we do this, if we calculate just two rates, a rate from here to here and a rate from here to here, and let's assume we did that over equal time intervals. This one looks like it's a little longer than this one, but let's pretend that they're equal. So that instead of the delta t for this segment, we take half of the delta t and get the green segments. The point here is that we stay more than half, better than twice as close to the curve. We improve our approximation to the curve by more than a factor of 2. So by doing twice the work, that is calculating two slopes, we more than double our precision if we take these segments as our approximations to the curve. So that by taking half the delta t, we stay more than twice as close to the curve. And you can see that by the fact that the furthest this gets away is about this distance here, whereas this one gets all this distance away from the curve, maybe 4 times as far as this. Okay? And on the average, if you take the area between this and the curve, between the red segment and the curve, it's much more than the area, total area between the two green segments and the curve. If you cut out this area and weight it, and then cut out the areas between the two green segments in the curve and weigh them, this one would weigh maybe 4 or 5 times as much as the total of these two. That's an important idea, again, when you get to calculus, but I want to expose these to the idea right now because it's not that hard to see. To actually understand it and understand exactly why it acts the way it does, and to prove that using derivatives and so forth in calculus, well, that's something that we do later. We don't do that now, but we get this general idea so that when we do encounter the somewhat difficult calculus procedures, we can concentrate on those procedures and not just on understanding what in the world this picture's talking about.